Thank you very much. It's a pleasure to be here, and I'm going to start off. I was asked to talk about the overall industry and then specifically Semico's view and forecast for some of the analog markets. So I'll spend a few slides talking about the overall economics and some of the concerns we have, look at some of the major end-use markets that drive the semiconductor industry, go over our forecast, and then I'll go into some of the information out of our MAP model, which is a database that Semico puts together that looks at the various end systems and looks at the semiconductor content within them. What I've done today is actually pull out specifically some of the analog information to show you how relevant it is. And you know, one of the things we say is that the microprocessors are the brains of the system, but really the analog is the heart of the system. It controls and manages the power supplies and manages how fast or slow the systems works, and also is the interface between the system and ourselves. And then I'll talk about some of the foundry information relating to analog and the overall industry. To begin with, I wanted to just talk about the overall economy. This slide shows you the U.S. Consumer confidence, and although the U.S. isn't a major manufacturing powerhouse these days, it does consume a considerable amount of products produced around the world. So when the U.S. gets the flu, the rest of the world gets a cold. And you certainly can see our concern here over the last few months is that consumer confidence has turned downward. And you know,
they're actually recording it, but they're not translating as well. So I think we can use this one.
Use this one.
Yes.
Okay. And you know, so our concern is that the U.S. economy and the consumer confidence is weak. It doesn't, and it's really driving a lot of the fears that the OEMs have seen over the last couple months. From the automotive standpoint, you know, we have seen a pickup in the automotive market. For about 2 years, we've seen automotive sales below the replacement value, particularly in the U.S. and Europe. The automotive market has seen a slow recovery in Japan due to the earthquake, but you know, that has given an opening for some of the other manufacturers to you know, pick up some market share. U.S. suppliers, Korean suppliers, as well as European suppliers. Recently, though, we've seen the industrial market kind of slow down. That's a significant market for the analog market. So, and the unfortunate thing is we see no short-term catalyst to really change the direction of the semiconductor market here over the next several months. This is our view of the world GDP. As you can see, after the financial collapse in the U.S., the world went into a recession. The world GDP went negative. We saw the world GDP for this year, we expect it to be about 3.8%, and which is down from 4.9% last year. And we are a little bit optimistic, thinking that next year we'll see slightly better economics from a global standpoint at 4.5%. This shows you our overall GDP forecast by country. What I can say is what's changed here from the probably last 3 or 4 months is we've really downgraded each of these regions between 1 to 0.5% to 1%. China still is up on the top, under 10%. And really what you see here is the Asian markets are doing fairly well. What's interesting is Brazil is now the 7th largest economy in the world, will grow just over 5% this year. And then, you know, the industrialized U.S., Europe, and Japan still really lagging the overall world economics. So I wanted to move on to some of the semiconductor end markets. Recently, this is kind of for the second half of this year, motherboard builds for the desktops and servers, they were slowing in the third quarter. We continue to see that slowing throughout the fourth quarter. For AMD, the good news is that they're selling out of CPUs, but they are a small portion of the overall market. We continue to see competition be very strong in the market. NVIDIA is introducing a 28 nanometer GPU this fall. That's going to continue to put pressure on AMD's graphics. In the US, particularly US and Europe, the back to school has been weaker than usual. We do still see the emerging economies being strong, but not as strong as they have been. And we're very concerned about Western Europe with their financial situation. It's beginning to look a lot like what the US did in 2008. The cell phone market, it's a great market for the analog industry. We still call the smartphones the promised land. It's growing at double-digit rates. If we look at printed circuit board suppliers, and what we've seen is robust sales for the third quarter, growing over 10%, but slightly weaker in the fourth quarter. If you look at the other segments of the cell phone market, the basic phones and the mid-range phones, those both have been very weak in the third and the fourth quarter. Looking at some of the major consumer electronics, again, we go out and talk to printed circuit board manufacturers. They tend to be a very leading indicator for us for semiconductors. And if you look at generally throughout the entire consumer market, set-top boxes, DVD players, video recorders, cameras, HD TVs, MP3 players, and e-readers, all are well below seasonal expectations for this year. I think the one exception has been the tablet, and particularly Apple has continued to do very well worldwide. We've seen recently in the last couple weeks, Apple's cutting orders for the Apple II. I don't think that's a lot to be concerned about because we expect to see an iPad 3 being introduced early next year, and our expectation is that they're clearing inventory out so they're not stuck with older models, which makes perfect sense. I was at CES at the beginning of the year, and we've been talking about this all year. There were 100 models being introduced at CES. I had said, after CES, this was going to be the next shakeout for the semiconductor industry. I actually really believed it was going to happen at the end of this year and into 2012. Quite surprised that it's really happened much sooner than we thought. So, Dell, they discontinued their Streak 5. They're trying to push their Streak 7. Gateway's out of the market. Nokia's out of the market. HP, dropped their tablet. We'll talk about their PC business in a little bit. RIM is hanging on by their fingernails, and we'll probably see that leave the market. So this is just a few examples, and I think we'll see a couple manufacturers survive and thrive, but I think it's part of the weakness that we see in the second half of this year. The other interesting thing that's happened this year is HP, the number one PC manufacturer, decided they were going to sell their business. This shows you what we think is the current market share. If one of the Samsung or Lenovo buy it, we've kind of plugged in what their market shares would be. So if anybody buys it, they'll end up being number one. What's interesting, I think, Samsung has already announced that they're not interested in buying it. So that really kind of leaves Lenovo or Dell to step up to the plate. And we really haven't heard any rumors about who might buy it or what will happen, but it certainly will be interesting to see how that will change the face of the PC market. So let's move on and talk about the semiconductor forecast. Now, many of you may not be familiar with the Semico IPI. It's called the inflection point indicator. It's a mathematical model that Semico has developed. We introduced it back in 2000, and it looks at about 14 different variables. Looks at billings and bookings, backlog and inventory for the major end markets. Computing, wired and wireless communication, biomedical, and consumer. We also include a few macroeconomic variables in our model, as well as booking and billing information from the printed circuit board industry. If we take this model and go backcast it and do a correlation, it turns out it has an 84% accuracy looking out, predicting where the semiconductor industry is going to be 12 months from now. So, you know, I can point out a couple spots here. This is the index kind of bottomed out in 2007. It matches up to the bottom that we saw in the industry in 2008. For a year, for that following year, the IPI predicted us kind of a sawtooth increase and a peak. That matches up to this little sawtooth increase and a peak. This is the financial collapse of the financial system in late 2008. The IPI did predict a downturn. We don't try to model the financial system, so it didn't show the dramatic drop, but it did accurately predict the peak and the valley. So what's interesting here is most recently is since May of 2010, the IPI has been going down, indicating that the second half of 2011 was going to be weak. And in fact, it has, the peak was in May, and we're seeing a downturn in the second half of the year. The good news out of this chart is that the IPI went away. The IPI bottomed out in February of this year. And we've seen a nice upward tick over the last several months. So what that tells us is 12 months from February 2011, the bottom should be February 2012. So that gives us a 3-quarter downturn, which I think will, you know, make sense when you hear my talk about inventories and capacity utilization. So our expectation is that we'll see the industry bottom out by early to mid first quarter next year. OEMs will realize their inventories are too low. They'll have to start placing orders to build product for sale for 2008. So what is our forecast? You know, we started out the year a little bit optimistic with single-digit growth rates. In March and June, we lowered our forecast. June results were very disappointing. They were much lower than expected, and we realized that the IPI actually was very correct, and that so our forecast for this year is minus 1.4% in revenue. I think the good news is that we upgraded our forecast for 2012 to 8% growth. So what's interesting, in about 4 months, 4-month time span, the entire industry reversed its attitude. So in March, after the earthquake in Japan, OEMs were scrambling to secure supply. The idea of having second source and building inventory to make sure that they could keep their customers supplied was, you know, paramount to a lot of suppliers. That has changed dramatically, you know, just recently, and now with the U.S. debt debate that was around the world, the European financial crisis, continuing worries about weakness in Asia. Now OEMs are very nervous. They're concerned about the consumer confidence, and we've seen the supply chain pull back and OEMs burning inventory in the third, and we think that's going to continue in the fourth quarter. And by first quarter, I think the industry will realize that inventories are below normal and will go back to more of a normal growth rate for the semiconductor industry. To kind of summarize our forecast, we continue to see semiconductor content be richer in all of the end applications. So You see more smartphones being sold. Those have more radios. They have more touchscreen capabilities. They have higher memory content, more application processors and baseband processors. But the consumer this year is spending less due to the consumer confidence. They're spending less on HD TVs, set-top boxes, cameras, and et cetera. We also have seen a lot of capacity utilization, new capacity coming online this year. This is the capacity that was built in 2010 and 11. It's being ramped in 2011 and 12, and that is adding to the ASP weakness that we see in the industry. As a result, we've seen capacity utilization being cut. So as an example, TSMC had a budget of $7 billion for CapEx in 2011. They spent $5 billion of that in the first half when the industry looked good. In the second half of the year, things started to look weak. They cut the $2 billion back 50% to $1 billion. So we're from just a few years ago where manufacturers are not quite as reactive as they were to market situations. Today, they are very quick to react. And that's really good news for the industry because I think it makes our downturn shorter than what they normally would have been. We are seeing aggregate ASPs this year decline. DRAM, as an example, has fallen 26% this year for average selling prices. But I continue to believe that we'll see the market overreact, and and that overreaction will drive an upturn in 2012. So kind of in summary, if everybody remembered last year in 2010, the industry grew 31%. Our forecast for this year is minus 1.4%. CapEx, which we started out at the year at about 16.5%, has now been scaled back to 14%. Looking at the fabs worldwide, we started the year at a capacity utilization of above 90%, and I think the overall industry will be well below 80% at the end of the year. And next year, we're forecasting 8% growth. So one of the things I wanted to do is talk about the Semico map model. And this is where we actually go through and look at the end applications out there that drive the semiconductor industry. And we forecast those boxes both in units and dollars so we can get the total electronic TAM. We also do a detailed bill of materials for each of the 5 years forecast. So what type of semiconductors go into each device. We try to represent a generic bill of materials for, say, the average notebook or the average tablet out there. And our list of bill of materials is about 175 different semiconductor devices. We also track average selling prices for our customers, so that's another input into this model. And so then from here, it's really simple math. We take the box forecast times the bill of materials. It gets us our unit total available market. Then we take the total available market and multiply it times the ASPs, and you get revenue. So it's truly a bottoms-up forecast for the semiconductor industry. The 40-some products that we track represent about 75% of the total semiconductor consumption in the world. We also take our unit semiconductor TAM by product and create wafer demand. So we can actually tell you how many wafers are required to supply 100% of the analog in a smartphone, or how many wafers it would take at what process technology for the NAND that sits in a cell phone or an MP3 player. So it's a great tool for planning, and it's online, available 24/7. So what I've done today is, since we're talking about analog, I wanted to pull out all of the analog information and kind of show you where we see the analog market going. So this is the total analog market by end application. So it's the kind of the total view of the market. It's broken out by consumer and automotive, computer, industrial, communications, and government. So this year, 2011, we'll see an analog market of about $43 billion. And we expect that market to have reasonably good growth by 2014. it will be in excess of a $60 billion market. So one of the things we say is around every digital leading edge product, there's 6 to 8 analog products surrounding it, making it a functional system. So if we look at from a unit standpoint for the entire analog market, in 2011 it's about a 100 billion unit market, growing to a little over 140 billion units by 2015. That's this slide, sorry. So let's peel that onion back a little further and just look at the analog units in the computing market. This shows you by specific product, whether we're talking about large scale, application specific analog, medium scale, small scale comparators, data conversion voltage regulators, reference, and amplifiers. So in the computing market itself, in 2011, it was about a 13 billion unit market, and we expect that market to grow to about 21 billion units by 2015. If we look at where all those units are going to go, this list on the right shows you the applications that we track, and over 50% of that goes into the desktop and the notebook market. And that's probably not all that surprising. It's still a significant consumer of semiconductors, both from the analog side and the digital side as well. If we look at the consumer market, it's much more diverse. In 2011, the analog consumer forecast will be about $17 billion, growing to about 23 billion units by 2015. And the breakout we show by the same application, the same semiconductor device as I did in the previous chart. And if you look at, so where are all those billions of units going in consumer applications? This here is a list of all of the products that we track in the consumer market. The biggest one over here is 20% of the units, and that's for HD TVs. The next biggest one is down here at 16%, and that's video game consoles. But it's still a fairly spread out market for all of the different consumer applications. Okay, there we go. Looking at it from the communication standpoint, in communications we include cell phones, and for 2011 we're talking about a 27 billion unit market, growing to about 42 billion units by 2015. And again, kind of the same format, we pulled out the analog products that go into the communication products. And then I did a very similar product. These are where the analog products are being consumed into by the product list that we track. What's interesting is this is the mid-range phones, and the green is the smartphone. That's 48% versus 35%. If I had pulled the same chart out for 2015, you would have seen these two pies reverse. So we're expecting the smartphone to consume about 45% of the analog for communication market, and the mid-range phones will shrink to about 35%. So one of the fastest growing segments for the analog market is the power management, and it becomes a critical piece. A few years ago we thought fuel cells was going to be mass produced and would go into consumer applications. It offered promises of very fast recharges and be able to power a lot of our products. That really hasn't happened, and the lithium battery technology has not improved as fast as our process technology and our consumers' demand for speed and process capabilities. So what has happened is the power management has become a critical piece of the electronic system and has become the heart of a lot of our portable devices. And really, when you look at power management, there's really two basic approaches. You can make a very simple power management system or a much more complex one. I think we're seeing a lot of movement towards the complex power management where you're really adding logic intelligence to analog control circuitry and incorporating a lot of voltage regulators versus just the simple power management which just controls voltage, just voltage regulation functions on the system. Portable devices really need to require high efficiency power management. And what is going to be successful are those people who offer a broad range of power managements that can operate over a wide voltage range. And coincidentally enough, I wanted to show you some examples of this, and it's probably good to talk about what examples are out there. And I think the Dongbu high-tech 1.18 micron BCD process is a good example of how customers can take advantage of the process technology that will allow for sophisticated power management. It offers a voltage range between 5 and 30 volts as well as dense 1.8 voltage CMOS logics. So this type of process technology is really what the market needs to develop the power management products that will manage our iPhones and our iPads and other notebooks in the future. I think looking at the overall analog market, I think we've seen a number of semiconductor companies, start to look at the analog market as a viable, profitable market. One of the metrics that we use in looking at semiconductor technology is revenue per wafer. And what's interesting is this black line is revenue per wafer for analog products. And what you notice right off the bat is it's really been over the last 10 years above $2,000 per wafer. And it's just recently gotten down to the $2,000 level. So compare that to the DRAM, which is this red bar. For most of the years, except for when there were shortages, actually DRAMs have been well below $2,000 a wafer. So you look at companies like Samsung who are building $10 billion fabs, and they're getting less than $2,000 per wafer compared to if you're in the analog market, you've seen very stable revenue per wafer, and it really creates a good market for a strong financial position. So I think that's why we've seen a number of companies really actually turn their focus away from digital into the analog market. And in fact, if you look at the green line, which is this one here, it shows you that the analog has outperformed not only DRAM, but actually the entire industry in terms of revenue per wafer. So a really smart place to be in this day. I also wanted to show you compound annual growth rates for the analog market. The bar on the side here is the total analog market. The green bar is dollars and the red bar is units. So in total, over the last 10 years, the total analog market in dollars has grown about, on a compound annual growth rate, about 3%. In units, it's been about 8%. What's interesting, you take over here, you look at power management, the compound annual growth rate has been about a little over 12%, about 12.5%. In units, it's been about 9% in dollars. The only faster unit growing is data conversion, which is growing about 15.5%, but they've seen tremendous price degradations over the last 10 years, and so their compound annual growth rate from the revenue standpoint is just above 4%. So, really the best place to be in the analog market appears to be in the power management market. It's a high growth, and ASPs has been one of the most stable categories out there. So if we look at the overall market, we're showing 2011 to being around $40 billion, growing to almost $50 billion, broken out by these major categories. The good news for foundry players in the power management, there's a lot of players out there. And so what I wanted to show here, and I don't want to present this as a comprehensive list, but this is just a list of some of the companies that participate in the power management. TI just recently acquired National. We rank them number 1, Maxim's number 2. Linear Tech's number 3, ST's number 4, but then below here are all the other a few of some of the other companies that participate in the power management, and it really shows you it goes from large companies like Samsung to small companies like Atmel, and it's a crowded market, but it's a good market for foundry players because that means they have lots of customers to service. And then there's just a few examples of some design houses that are specifically focused on power management. So I wanted to also now give you a brief view of some block diagrams of some typical systems, and point out where power management fits. This actually is a mobile internet device, and all the brown blocks, which are up here on the side, down here on the bottom, are all power management products. And I think what it points out here is that how important it is, and really the power management units relate to the interface between us. It's the speakers, it's the keyboard, it's the touch management, it's managing the charging and the power to the application processor, as an example. This other example is an example out of the industrial category. There's thousands of industrial products out there. They consume about 25% of the analog products. This is a gas meter. They're typically also battery operated, so you have power management down here. And it shows you, here we have there's probably 3 or 4 different power management functions on a system that has 1 microprocessor, a few interfaces, and some sensors. So again, just one example of how power management, it really finds its way into every semiconductor end-use system. So let's look at, for a few minutes, the analog production capability in the semiconductor industry. One of the things that Semico does is we keep a fab database for all of the factories around the world. And when we go and mine that database, we found 116 analog capable fabs around the world. 38% of them are in the Americas, 47% are in Asia, and only 15% in Europe. What I actually found surprising is, what type of wafers are produced in those 116 fabs. And, there's still 49 fabs that use 150 millimeter wafers, another 49 that use 200 millimeter wafers. What I was surprised to find is there's still 75 and 100 and 125 millimeter wafers out in production. But I think this 49 we'll see over the next 5 to 8 years probably migrate to 200 millimeter wafers as the analog market grows. The 200 millimeter used equipment market is a great opportunity to increase capacity at a very cost-effective route. And the one 300 millimeter plant that we're showing is the TI fab that they bought the old Kumanda DRAM fab at a very good rate. So they got a great deal, and so we'll see how that actually, if that really changes the face of the analog market. This slide just shows some of the names of the companies and where their headquarters are. Again, I didn't have enough room to put all of the companies out there, but it just gives you a good flavor for who's in the market and where they're headquartered. And it's from, you know, the big companies like TSMC and IBM to some of the more focused companies like Dongbu and XFAB. So, one of the things that we do at Semico is we do market shares for not only semiconductor IDMs, but also for the foundry players. This is our market share information for 2009 and 10. Of course, the big players, TSMC, UMC, Global Foundries, they're up on top. Most of their revenue is derived from digital CMOS. Down here from 5 through 8 is really the more specialty DRAMs, specialty foundries that are typically focusing on analog. Good news for this presentation is Dongbu turns out to be #1 of the specialty foundries, outperforming Jazz, Vanguard, and Magnachip. And I think what we've seen here is the success of some of these specialty foundries has actually encouraged a number of the larger foundries to make an entry into the analog business. But I think what we've seen from what we talk to our customers is that the analog market is a very complex market and needs some specialized process technology. And we believe that there's a strong place for the specialty fabs that are focusing on analog and power management to not only survive but actually thrive. So let's look at one of the things we also do is look at total wafer demand. This is our total wafer demand for the industry, and this bottom red part is the analog portion of it. It's a small, it's about 15 to 20% of the overall market, but this is in wafers. If you look at the die per wafer, you obviously get you get a significantly higher number of die per wafer than you do on the DRAM side. But it is a significant portion of the market. If we actually take a look at the breakout by products, the analog is the red piece on the top, and as you can see, it's becoming a bigger portion of the total. The big blue bar in the center is the MPR and the consumer. This is basically all of your digital products. So this is your baseband processors, your DSPs, your graphics. So basically, this blue bar here is basically TSMC, UMC, Global Foundries, and then the others are more of your specialty type products. If we look just at analog wafer demand by technology, so I've taken that red bar from the previous chart and expanded it by process technology. And what I just wanted to point out here is that if you look at this, at 130 and below, even out in 2015, is still a majority of the wafer demand required by analog products. So what we see is a longevity in analog that you don't see in many of the other digital process technologies. And with that, I appreciate your time. I think we probably have maybe a couple minutes for any questions if there are any.